Welcome back to another episode of the Dig Deep, the Mining Podcast. And today's guest is Denis Laviolette, who's the Executive Chair of GoldSpot Discoveries, who are a technology investment company that uses artificial intelligence and machine learning to significantly improve mineral exploration targets on both regional and local scale. Denis is a geologist by background and has worked on 3 different continents, Canada, Norway, and Ghana, during his career, with a range of experience working on advanced mine operations, startup management, grassroots exploration, and finance and acquisitions. And now he's bringing machine learning to the resources sector. So that's welcome Denis to the podcast. How you doing, Denis?
Thank you very much. Very well, thank you. How are you?
I'm good, thank you. Good for a Monday morning. Monday afternoon, Monday morning your time. So let's get straight into this, and wondered if you can tell the audience a little bit more about your background, your career, before I've got a number of questions to ask you. So fire away.
Sure. Well, as you mentioned, my background was I was a geologist for a long time, working all over the world in different sorts of projects. Where I got probably the most, I want to say, exposure to the most stuff was with Pine Tree Capital as an investment analyst on the buy side. So I transitioned from geo to that role, and then basically it was sort of like half a dozen to maybe 3 or 4 to half a dozen companies coming in on a daily basis, presenting their stories, presenting their stuff. I was constantly on the road, going and seeing things, site visits, that sort of thing. We had over 400 investments in junior mining, and so across different commodity types. And so I got to meet tons of teams and really get my feet wet and get exposed to as many possible mining stories as one could imagine. And then really just once I recognized this idea with Vincent and his team and machine learning and AI and crunching big data to vector in on targets, I realized what sort of an edge it could give to most explorers. And so that's where GoldSpot was essentially born.
Yeah. So I just wondered if you can tell us a little bit about GoldSpot, sort of obviously how it's formed, and a little bit of the makeup of the actual company.
Yeah, so I mean, again, so basically we, myself and CJ and Colin Cattell, we met up with Vincent and his core team back in the early days, which he was based out of the Institute of National Research in Quebec City, working on this machine learning data science program with a bunch of about 6 other people. So we basically set up the company that way. We joined forces. Vincent today is CEO of the company. I'm executive chair. CJ is also an executive officer of the company, chief business officer. The way the company is set up today, we've got pretty much I would say about 45 people on staff, technical people. About a quarter of those or so are PhD level, the rest are master's level individuals. And then we have our executive management branch. In terms of ownership wise, from a capital structures perspective, Palisade Gold Corp owns about 20% of us, Eric Sprott about 20% of us, and management insiders, etc. Again, in that sort of 20% range. And then the rest is out there in retail, high net worth, etc. Some institutional.
Okay. So obviously big data, artificial intelligence, machine learning, of all sort of new technologies that mineral explorers are adopting into their vocabulary as they look to obviously accelerate exploration, discovery and production through increased accuracy. How does Spotlight address and solve these challenges?
In terms of accelerating things, well, basically it's about reducing risk, right? So, the exploration game is a risk reward game, and you need to risk money, and the reward is potential discovery. And so, if you can use machine learning and data processing if you can get more out of the data that you have, and have a more refined targeting approach, ultimately it's going to mean that you may need to spend less money to have the very same discovery, or even potentially more. So it improves that sort of risk reward profile, reducing the risk of the exploration side of the coin and the cost ultimately. And that's where it matters to investors. The way that we do that's kind of weird. It's not so straightforward in the sense that like we take all of this data and we click a button and use AI and some AI program and spit out a bunch of targets and save people money. It's a lot more thorough than that. We've actually gone down. Our team is comprised of many very specialized individuals that bridge domain expertise from some subdiscipline of geology or geophysics or any sort of subdiscipline of geoscience, we'll say, and computer science and machine learning. And so we have these real dual people. And so when we get into any particular mine project or exploration project, whatever it may be, their data sets are different. The problems they need solving are different. And so our team is there to create a very bespoke solution for to improve that exploration process.
Yeah, and in terms of obviously data, how is the data presented to you? I mean, if you're looking at a particular project, do you have some sufficient data when you're sort of analysing a particular project or a resource? Do you have to really go out and research even more? And how accurate is the data that's sort of given to you, or do you sort of have to sometimes look in between the lines and try and not necessarily guess, but try and predict if you're given a set of data, which could be quite a few years old, how do you sort of process a lot of that information, and is it necessarily correct that obviously the data that's been given to you?
Yeah, that's kind of where the most of the work is in cleaning and homogenizing that data, basically going through that old archive data and cleaning it up. I mean, as you can imagine, different vintages of geological staff or whatever life cycles of these companies and these projects, they go and they ebb and they flow. So you may have 3 or 4 vintages of exploration dating back to the 1980s, in which case the data that comes out would be different varieties. You know, you'd have everything from paper maps to, you know, digital 3D models. And so, our job is really to spend a lot of time, and, you know, quite frankly, that's where most of the cost is for us, is to go in and roll up our sleeves and go back and homogenize and clean and stitch together all that old data, and then pull in some of the new stuff. We actually have a really cool tool that we've built to help us out with that problem. So just a very specified example is with core logging. So, you know, when someone drills a hole or something, they log a particular meter of core, and they call that, you know, a geologist would then look at a core box of, you know, the core that comes out of the ground and read it like a book and essentially document all of their observations. And those observations are then taken by someone else, or maybe the same geologist later on, and you would take those observations and create, you know, shorter codes so that you could visualize them in 3D and then see, you know, okay, from 130 meters in this hole to 165 meters in this hole, you have this rock type. You maybe have a vein or some sulfides. You maybe have, you know, some chalcopyrite, whatever it may be, whatever the mineral you're after. And so that's, you know, this typical process of logging core is a very manual one. But as you can imagine, when you go through the vintages of data, as you're saying, or as your question was asking, you would see differences. And so geologists at different times would be calling the same rock different names. And this is really problematic for the industry, because when it gets time for that person to model the geology, they're, you know, going back and looking at, you know, 5 or 6 different rock codes of what they assume to be the same name. So one of the things that we've come up with as an industry, or one of the things we spend, you know, millions and millions of dollars on every year, is to relog. So we have to send all of our people into the core shacks, and we pull out all of these old boxes and we go back through and relog them. This is a very time-consuming process and an inexpensive one. So we came up with a tool called LithoLens, which again is an AI-driven tool. But basically, we take the historic photographs. So ever since basically CIM standards as of about 2000 were that every company that drilled core needed to photograph each box of core with basically a Canon power shot or whatever, took a core photo. And then that photo was archived for legal reasons. Should anything happen to the core or whatever, they could prove that it was there. So we came up with a software that basically makes use of those photos. And so we can take all of those photographs and use AI to basically relog all of the rock types based on those photographs. And even as you grade into better quality photos, and you can imagine some of the poor quality photos at the time, you start to be able to color treat them and balance it all and make it work. So it's pretty amazing what they can do with technology today, and how we've taken that to solve that very simple problem, which is how can we just relog all the core with one very consistent, very reliable, homogeneous data type. The computer calls every time the rock the same name and all that kind of stuff. And it allows us to make some really, really interesting and sophisticated geological models too, because then we can start to bin things together and break different little nuances out that we couldn't do reliably before. Yeah, machine learning and AI and data cleaning is a big step, but it totally affects what you can do with it downstream.
Yeah. Obviously, you mentioned your team, and obviously you got a lot of PhD and masters people on your actual team, and obviously it seems to be a key differentiator and an incredible asset. How important is it to have both data scientists and geoscientists on board to work through all the data that you have to go through, obviously, which you've just been explaining about?
Yeah, it's super important because when you have a geoscientist can recognize that, excuse me, just getting over a cold here. A data science can recognize some of the issues in the core logging. Like, let's take the core logging as another example, because we just talked about it. If I just had a data scientist, they may have traditionally taken all of those historic logs that geologists had logged at face value, and then basically tried to apply machine learning and data science techniques using all of those logs at face value, not recognizing that the geologists for the last 10 years calling this rock type gabbro was also like if you go back 20 years, there was another company under operation and they were calling it a diorite. And those two rocks are actually the same rock, but those two companies had different names for those rocks. And so if you have a data scientist without domain expertise, the data is full of mistakes and issues that could cause big problems. And so let's say they take that example data set I just gave, and a data scientist would process that and come up with some association with diorite. Well, they would miss all of those associations with gabbro potentially. There'd be like all those other instances where that same conditions were met. Or maybe they come up with a false association with mineralization or something like that. And so it can really, really make mistakes. Another good example is geophysics. You take geophysics data, airborne magnetic data, or electromagnetic data. And if you had just a data scientist, they would take maybe the grid file for an electromagnetic survey, and it would be this big, beautiful, colorful map. And then they'd have this big, conductor, this big superconductor running across the property. Well, that's a power line, but a geophysicist knows it's a power line and knows how to treat it, how to extract that noise out of the data and work with the residual data to get something out of it. A data scientist wouldn't know that. They would, leave the power line in there because they would have no idea that it's a power line to begin with. And so, doing AI and machine learning for mining and mineral exploration without proper domain expertise is can be really dangerous. And I think that applies to any field, really. So you need computer scientists, you need data scientists for sure, but you need good domain expertise as well.
Yeah. Is it really about standardizing? Obviously, all the projects you're involved in, is it really about standardizing and obviously categorizing certain things, as you've mentioned, into certain names so that everyone can understand it if they go back to that information in X amount of years' time?
Yeah, absolutely. I mean, again, it's about that front end work, that standardization, homogenization, cleaning of the data. Sometimes you get into a data set and it's already pretty clean. Very little needs to be done. And sometimes it's not, sometimes it's a mess. And so, but by the time we're done with it, everything is perfectly, very well documented, very well organized. Everything is working together in the right way. Any coordinate issues that sometimes existed or problems, we fix those. So we put a lot of work into cleaning data and sourcing external data too. So sometimes companies come with us with their data sets, and there may have been a survey flown by a neighbor 20 years ago where that land package that they own actually pertained to that neighbor, and their land is covered by this other survey, but they didn't have the data for it. So we do sometimes from time to time come into it with a client and end up bringing in all kinds of information that they didn't even know they had access to.
Right, got you. So what kind of companies and deposit types benefit most from your services? I wonder if you can walk us through some of your work and some of the projects that you've been involved in, as well as some of the small cap mineral exploration companies and how each have benefited.
Sure. I'll give you a few examples. So I guess we'll talk about orogenic gold. That's the big one. And why orogenic gold? Well, orogenic gold's kind of like the most complicated of them all. The idea is that, machine learning and data science and all of these tools and techniques, this edge is required on a certain corner of the market. And that corner of the market is big, deposits are getting deeper and deeper and harder to find, right? So particularly orogenic gold deposits or gold deposits in general. And so it's a good candidate for us because we can make a mark on that. If I were to take, say, iron ore as an example, iron ore would benefit very little from machine learning in data science, albeit we have done some work with an iron ore company, believe it or not. But conventionally speaking, for exploration purposes, a magnetic like a magnetite deposit shows up pretty well on a mag survey. They can, that's basically a beautiful tool they have to x-ray the earth and see where all their iron ore is for the next 50 years. So they don't really need an AI company to come in and tell them that. But yeah, orogenic gold is great. I think any of the base metal stuff, basically we're commodity agnostic, any sorts of things. We've had tremendous successes in epithermal silver plays. We've had tremendous successes in orogenic gold, of course, and newfound gold, etc. We've had some really great successes in base metal, in Sudbury, nickel, that sort of stuff with Valet. So yeah, I mean, we've worked on different project types and deposit types. Really, any project that I think has a fairly rich amount of data, but where you have a hard time finding that proper analog, that proper, silver bullet for discovery. I think that's where you want to start looking at what we do, to possibly combine all of those layers and find and tease out subtleties that may not be so obvious. And I think that if most geologists around the world find themselves in that situation, whether it's trying to predict the right rock type, or it's not just about always predicting a deposit or predicting where mineralization can be. Sometimes it's a very key rock type that they're interested in, and you want to predict more of that rock type. Or you want to have a certain structural regime, and you want to find other areas that have that same condition where those conditions are met. These sorts of things, and so it's the components as well as targeting mineralization directly. But again, yeah, some good examples being gold. I would point everyone to Newfound. I think we put out some really interesting stuff with Yamana a couple of years ago on with their project. We've got some base metal stuff with Valet. I don't think there's much to read about in the public domain about that, but anyway, nonetheless, an interesting endeavor. Yeah, I mean, there's a whole laundry list of great companies that we've worked with and good examples, and I think there's quite a bit of it. One good example that viewers, if they're really interested in looking at some of the work we do, TriStar in Brazil was a really good example of litholens and the value of machine learning and refining your understanding of geology and the geological model to make a predictive geological models to find more. And so with them, they're sitting in this big basin, and you get a really good sense of what the potential blue sky could be on that example.
Yeah. Let's talk about some of your recent success cases and how you work and how your work continues with them as they leverage your sort of data insights.
Sure. Which one would you like to talk about? Newfound gold, maybe?
Yeah, whichever one you feel is, I suppose, most exciting, most challenging.
Well, again, I'd say Newfound is an interesting one to talk about there. Yeah, I mean, it's challenging. It's tough because the whole project's undercover. There's a lot of things that matter. There's a lot of features that matter to vector in on mineralization, but then you find mineralization that doesn't fit the same styles as the other stuff that you've found. And so the challenge with that project is it's so large, and there's so much data, and there's different flavors of mineralization types. So it really ends up with like everything could be a potential situation, which I don't think gets us any further ahead in some ways. You know, it's been challenging because you want to be able to rank things according to their possible value in the current market conditions and what the company is currently exploring for. And so ranking things like very high grade targets, you know, where are those versus, because gold there, you can almost find gold there anywhere. I mean, that's what's so interesting about that area. Yeah, I think that's some of the challenges with it. Yeah, being cover. You'd have, you know, you don't really have any particular geophysical layer or anything like that that's a dead ringer for mineralization. So nothing is super obvious. It's all very, very, you have to combine everything to get the best results.
Yeah. You recently announced an acquisition of Ridgeline Exploration, a geological and logical field services firm in Canada, as well as a new applied geophysics division. How will this complement your AI products? And as you note in your press release, further reduce risk and increase efficiency for the industry?
Yeah, so the Golden Planet deal. Are you talking about Ridgeline, sorry, or Golden Planet?
Ridgeline.
Oh, Ridgeline. Okay, yeah. So Ridgeline is interesting. So Ridgeline, that was basically they have some geochemists, they're like a technical services group. They had some geochemistry team, geology team, and they would do work for the industry, generating substantial revenue, things like that. But they also had some geophysics units too. They had some airborne geophysics devices and things. And what we wanted to do was actually take that business in and build on that. So this is building GoldSpot towards a data collector. So one of the things we've been obviously very sharp on has been data processing. We've got a great team for that. We can do some really cool things with data. One of the things we haven't been offering as a service has been the actual collection side. And that's where Ridgeline really fits in. So with Ridgeline, we're going to build out our deliverable base there to be competitive with other geophysics companies in the space, and basically offer it to our clients, as well as some of our bespoke processing methodologies and things to get the very most out of it. But our idea there is to lean into the geophysics data collection side.
Okay. You're developing 40 plus R&D products from drill core imaging to 3D geophysics innovations, and building what seems like a toolkit for the industry. Why don't you talk about some of these products and how they change the way companies are processing the data?
Well, I mean, right now, a lot of our products have been offered to clients that we work with very closely, and that are customers of ours, and so on. And so we're sort of at that inflection point now where we're going to go out to the broader market and package these things up for everybody to use. So I guess we still have to wait to see how the overall market's going to react and adapt or adopt, I should say, our toolkit.
Yeah, and have you got a time frame around that at all?
It's kind of like when it's ready, it's coming out. So, I mean, I would expect to see some movement this fall.
Okay. And as you transition to offering more software products, where are some of the big growth areas you're targeting?
Yeah, some of the big growth areas we're targeting again. So I think geophysics data collection, that's one of them. But in terms of software as a service, I think it's going to be with the core logging software side. So that's a great place for us to get into geophysical modeling and versions, that sort of stuff, making it simpler and more easy for geologists to play with their data without having to rely on other people. That's going to be another cool toolkit that we're going to put out. So I think those are probably the key spaces we'll focus on for now.
Yeah. And as a conclusion, what's the sort of 12 to 18 month outlook for GoldSpot?
Well, we've had a lot of success with Golden Planet, so I suspect that we're probably going to do a couple more deals of that sort of type nature, generative business ideas, I think we'll say, generative discovery ideas. We've got, I think in the next 12 to 18 months, I think GoldSpot's going to be a very key player in a lot of deals across this market. And one that I think most people will want in their story. I think we've built a great track record with our company, a great following, and people tend to get involved in the names that we get involved with. And so if that trend continues, then GoldSpot should be a first phone call for anybody that finds something interesting and wants to take it to market or wants to go out and raise some money.
Yeah, no, that's great. Denis, really appreciate your time in give us an overview and understanding of what you guys do at GoldSpot. It certainly sounds interesting. And I think obviously it's going to be a growing market, especially with obviously data, AI, and the need for good up-to-date data that can be used. So if our audience wants to reach out to you, if they've got any questions, how can they go about doing that? And are you on any sort of social media platforms as well?
Yep, Denny at goldspot.ca is my email. So anybody can feel free to send me an email or look me up on LinkedIn. Yep. Okay.
Yeah, and we'll include those in the show notes accompanying this podcast. So yeah, really appreciate your time. Those that are listening, hopefully you got a lot out of this episode, especially with obviously talk around data collection, which I think obviously is important for the industry. So appreciate if you can share this episode amongst friends, family, other people in the industry, so they can have a chance to listen to Deniss and see what GoldSpot can actually offer them. So until next time, happy mining.
Thanks.